Consider the two tires shown, each assumed to be bearing the same load. If the left tire is properly inflated to 30 psi, estimate the pressure in the underinflated tire to the right. Anyone ever find their tires on their car maybe look more like this one? I've copied this picture into my whiteboard space because I've set up my pen to only write in that section, so this lets me look at this in some more detail. And the formula I'd like to use to kind of help me understand this is pressure is equal to force over area. And we're assuming, since it says that each of these tires is bearing the same load, so maybe it's one is on one side of a car and the other's on the other side of the car, and if the car is reasonably symmetric, that means the same force is being applied to each one, which really means each tire is responsible for the same kind of or bearing the same upward normal force onto it. The relationship, therefore, of pressure and force over area suggests that pressure is inversely proportional to that area, which, if the width of the tires is the same, and I'm going to assume that these are two tires of the same type, that the only difference is that one is not as well inflated as the other, area being length times width would imply that area is proportional to the length that is kind of flattened here on the road. In other words, that lets me say that pressure is really inversely proportional to that length. So if I look at like this length here, just gonna draw a little line there, versus this length there. And maybe, it might be hard to eyeball, but I've got some tools here that might help me out a little bit. I'm going to copy this one here and then move it close to the other one. And I think now that we're looking at them close together, it looks like that length of the underinflated tire is roughly twice as long as the properly inflated tire. And given that pressure is scales inversely with that length, that kind of flattened length, the length of contact with the road really, that would mean that this tire should be at half the pressure. And so therefore, since the pressure of the properly inflated tire, this one is 30 psi, which is another unit of pressure, right, pounds per square inch, then this one should be half that, since it has twice that area of contact with the road. So I'm going to say 15 psi, so therefore 15 psi is the answer, and we can check that and see that that is correct. Maybe a big takeaway from this question, though, is about proper tire inflation. Physics has something to say about that. How long would it take, or how much would a tire need to be underinflated before you're going to notice it visually? This inverse scaling between this surface contact length and the pressure means that if you're a little bit, like if you look at 30 psi versus 25 psi, it's probably only going to be a very slight difference. And even when it's at half of the pressure it's supposed to be at, this length, this is not, I've seen flatter tires than that. So if you rely on that to know when to inflate your tires, it may be bad news. So that's maybe an interesting little takeaway from this question.